Today we'll speak about, yes, our latest addition to our portfolio of integrated systems. We will discuss multibeam echosounders. I will start with a little bit of theory. What is bathymetry? Bathymetry is measurement process of the measurement of the depth of water in different water bodies, in lakes, ponds, rivers, oceans, seas, pools, in any water bodies. Interesting that definition of bathymetry is measurement of the depth, but interesting fact that most standard product is not depth of the water, but elevation of the bottom. Because depth is not constant, it can vary because of tides. Ponds can be filled, pumped out. But elevation of the bottom is more constant data, and usually standard products of bathymetry will reflect elevation, not the depth. But of course, reporting in the terms of depth, of the current depth at some moment, it is also possible. So typical applications for drone-borne bathymetry are not related, of course, for the open seas or oceans, because bathymetry using any sensors mounted on the drones usually reasonable for not big survey areas. So if you need to survey ocean, you need to survey ship. So if you need to survey square kilometers, maybe you need a hydrographic boat. But if we are speaking about a lot of jobs, thousands of different jobs to survey ponds, lakes, making cross sections in the river, especially when hydrographic boats are not available, drone-borne bathymetry can be beneficial in terms of logistics, in terms of costs, and in terms of time as well. So we are supplying bathymetric systems starting from 2021, as I remember. 5 years ago, we introduced to the market integrated systems with single beam echosounders, and we supplied from my brain up to a couple of hundreds of such systems. And also we supplied a lot of systems with low frequency ground penetrating radars for freshwater bathymetry. And now we know most popular scenarios of for the drone-borne bathymetry. First of all, it's a dredging planning monitoring, because in many cases areas for planning for the dredging are quite small. It can be just some pond which should be cleaned. Second very popular scenario is construction planning. When you need to build something in the water or close to the water, you need bathymetric data. And also areas are usually, if we are not talking about some huge new port, usually areas also quite limited. Very popular scenario is surveying of open pit lakes to monitor volume and build up of sediments. And scenario very specific for drone-borne bathymetry is surveying of ponds or storages with aggressive or dangerous liquids, because in many cases even access to the water body for humans without some protective suits is strictly prohibited. But using drone-borne sensors, you can start from hundreds of meters from not water body, liquid body storage, and make a survey without close proximity to the dangerous liquids. In such case, even using suspended echosounder, only echosounder will be submerged to the water, to the liquid. And last years, more and more popular scenario is river cross sections profiling. First of all, to collect the data for the river discharge monitoring and at the end to predict floods. So it's few words about bathymetry, and standard tools for bathymetry are echosounders. They were invited, as I remember, more than 100 years ago. It's pretty old technology. I mean single beam echosounders. Principle of work is very simple. It's a device like loudspeaker. It emits high frequency sound down to the bottom, to the direction of the bottom. Sound travels through the water. Part of it will be reflected back, and device will measure the time which is required to travel from device till the bottom and back. As speed of sound in the water more or less known, we can calculate depth below echosounder or below transducer. That technology is old, very robust. It is used and will be used for many years, of course. But it has obvious drawback. It measures the depth in single spot below transducer. In single spot, not in the point, because beam is not extremely narrow. Usually it's few degrees at least, or can be 20-30 degrees for low frequency echosounders. And in readings, you will have data which reflects some average depth in footprint. If you need to survey bottom your water body with high bathymetric coverage or density of measurement points, single beam technology may be economically not reasonable because you will need to make too many survey lines with very close distance between survey lines. For that reason, at some point, some time ago, we invited devices called multibeam echosounders. Physical principles are the same. They measure the time for the sound propagation from device to the bottom and back, but they emit not one impulse, but they measure the distance till the bottom in many points. What is benefit? Of course, much better coverage or density of the data, and we need in many cases to conduct to plan our survey with much less survey lines to have the same density of the data. Here on the photo, here is single beam echosounder what we supply, and multi-beam echosounder head. So, and scale is more or less the same, but that particular models what we supply, very compact and very light to be mounted on the standard commercially available drones. So, what are benefits of multi-beam echosounders comparing with single beam devices? Again, with multi-beam, we will get much better data density and data resolution, and much better bathymetric coverage. And in many cases, much better productivity of survey to collect required data. But single beam echosounders will not die, of course, because first of all, they are simpler and in general more accurate. They less depend data, what we can collect, less depend on the precise sound velocity data for our water body. They are compact dual frequency devices, which allows to profile not only top of the bottom, but only penetrate to some degree through sediments. And we will have measurements for top of sediments and hard bottom. They are multi-frequency, multi-beam devices, of course, but they are very bulky and heavy. They are not suitable for the flying drones at all. And single beam devices with the same weight and size usually have much longer depth range. So if we will compare devices what we propose, that device, single beam device from membrane, from memory, has a maximum range 200 meters. Multi-beam device, what we integrated, has a maximum range 50 meters, 4 times less. So to demonstrate difference between echosounders, between different technologies, I can show you a couple of data sets. I need to scroll my presentation, sorry. It will be here. This one. Here is bathymetric data collected from our house lake in Latvia. Our office is here. Lake is here, just 5 minutes drive. And I suspect that it is most surveyed lake in Latvia, maybe in Europe, I don't know. Because for that lake, we have actually hundreds of data sets collected using different sensors, technologies, and different conditions. So here I can show you data, overlapped data from single beam echosounder, this stripe, and partially overlapped data collected using multi-beam. So here is overlapped region, and we can see that depth or elevation is the same. So differences just average differences just a few centimeters. But of course resolution of multi-beam data is much better because again in single beam data all readings are averaged across footprint of the sound beam, and also here we have don't remember exactly around 6 survey lines. So data looks smooth and averaged. In opposite, multi-beam data is very detailed, and we can see very small features on the bottom, like here. So single beam data was collected using not our system, using Apache 3 unmanned surface vehicle, which we use as a kind of benchmark because it is trusted by many surveyors. Sorry, was the data visible on the screen? I forgot to ask Camille.
There is a drone GIS visible.
Okay. Yes. Super. Sometimes I forgot to share all the screen, so I continue to speak, but
it's all good.
You can see only the same slide. Okay, so yeah, added one more multi-beam data set, and we can see actually the same. In multi-beam data, detailization is much higher, but in average, depth and elevation is the same as from single beam. So I'll return to my presentation. And yeah, bit more information about device what we integrated. SPH don't manufacture sensors. we integrate sensors with drones. We develop data logging. We develop surveying, data processing workflow. So for integration, we selected device called Cerulean Surveyor 24016. At the moment, it is the only option on the market suitable for UAV integration because of its small weight, below 800 grams in the air, and quite small size. It is approximately that size. That device has integrated inertial measurement unit to measure pitch and roll of the sensor, and pitch and roll readings are going connected with bathymetric data. For that device, manufacturer provides not only their software, but also open software protocol, which allows us to program data recording software because, of course, standard software, which is designed to run on Windows laptop computer, on some survey bot, is not suitable to run on small onboard computer of the drone. Here is link for where you can find the specifications, but main parameters of the device. It is not high-end, like what we can find on the market from such manufacturers like Kongsberg or Norbit, but high-end devices are much more bigger and much more heavier. So again, that's the only option what we have at the moment. Not high-end means, first of all, a limited number of virtual beams, just 16 beams, and in opposite with high-ends, which can have up to 200 or even more virtual beams, and it has a limited range, 50 meters, but that covers almost all possible surveys of inland waters or construction areas, especially in inland waters. That's the main differences. In terms of accuracy, we still need to collect more data, but you saw in comparison with single beam, quite trusted single beam system, it produces the same results. So difference what we see in the data is actually minimal. And system itself, integrated with the drone, has many components. Standard recommended system to carry multi-beam system is from DJI. Currently, we use that sensor with DJI M350 or DJI M300, small TIPA, M300 and M350. Support for newest DJI drone M400 is coming. And also the same kit, the same set, compatible with non-DJI drones based on echosounder autopilot with Ardocopter firmware. It covers the range of American-made drones, for example. I can name Inspired Flight 1200 and 800. I can name most probably Whisper. In theory, any drone with suitable payload capabilities, around 3 kilograms. Standard components include onboard computer, also our onboard computer called SkyHub. It is here, mounted here. And it implements not only data logging for sensor, but also implements terrain following, because for survey, you need to have, drone should have a stable set altitude over the water surface, not only for accurate readings, but also for safety of the drone. That system uses a radar altimeter. It is not very visible here, but it is mounted in front of the drone. Multi-beam sensor is mounted on foldable arm. It has two hinges. This hinge in knee in the middle of arm is actually for more comfortable landings and takeoffs. Upper hinge has two dimensions of freedom, up and forward and back, and left and right, but it prevents rotating of the sensor in horizontal plane. Why? Because for every reading from multi-beam system, we need to know exact orientation of the sensor in space. We need pitch, roll, and heading to restore coordinate of every reflection in space. So we need to know full attitude of the sensor, coordinates, and pitch, roll, heading. So heading is coming from drone, and also coordinates also coming from drone autopilot. All Blackmagic is implemented inside of onboard computer called SkyHub. For flight planning, we provide UgCS Expert flight planning software and UgCS Companion, which will run on drone handheld controller. For data processing, at the moment, we recommend Beamworks suite, and we expect that full multi-beam support will be implemented very soon in HydroMagic. It is almost ready, but they, manufacturer of HydroMagic didn't implemented all necessary for the path test. It is process of alignment of measurements. How system works, here is link to link it in post, and here you can find a video with system in action. So sensor head is submerged to the water, of course, and drone is flying in fully automatic mode using data from radar altimeter following planet survey lines. I hope that video was visible, but you may have a link to it. I will post it in chat. Actually, we started to work on integration and implementation of the system approximately 1 year ago. It was a pretty interesting and complex engineering task. Just for fun, I can show you the very first prototype. As usually, a lot of zip ties, tape. To prevent rotation of the sensor, we used cable protector here. So it was very first prototype 1 year ago. But interesting that it worked. It worked, but not with a high quality. Data quality was not very good, but it is how we started integration and development. Yeah, the same prototype. So, how multi-beam data looks? If you have experience with airborne lidars, it looks the same, actually. It looks the same. You will see something very similar to point cloud, or just a point cloud. And on board of SkyHub, we log data in a file format called svlog. It is proprietary format of manufacturer of multi-beam sensor, Cerulean. But that format is documented, and we decided to use that format because Cerulean provides software called SonarView. So right after the flight, you can easily assess quality of the data, or just check that you have recorded data using software which comes for free together with this system. From sonar view, you can export data in a couple of more formats, including point cloud. But option to export point cloud and use some generic purpose point cloud processing software for the data processing is kind of hardcore option, because much more convenient if you will use software built for the multi-beam data processing, not for the airborne lidars and not for point clouds. Why? Because you need to, at the very first survey, you need to collect data for the stripes or data alignment. That process called in multi-beam world, that process called path test. So how it looks? You need to collect data over 3 or 4 survey lines using recommended specific pattern. Specific pattern is not complex actually. Data should be collected over the same line in 2 directions, and one more line in 2 directions with overlapping 50%, overlapping of the data on bottom. 50% or more. Having data collected using that pattern, we can use software utility called Beamworks AutoPath to find correction angles for multi-beam head, pitch, roll, and heading. Usually that process works in 1 click. So I will not dive deeper in full data processing workflow because it will take another couple of hours actually. I mean step-by-step demonstration. But at high level, you need to import data for Z lines in Beamworks AutoPath. It will automatically find the pairs of the data which are suitable to calculate corrections of the angles. And you need to click bottom AutoPath. And it will automatically calculate correction angles. That correction angles will be used for data processing, can be used for data processing for all surveys conducted using the same system in the same configuration. So you don't need to do that every time. Just once when you first time set up and checking the system. I tried to play with manual alignment, making some slight corrections of the angles, but in fact, maybe I'm not experienced enough to get better results. So automatic algorithm for me provides better results than I can find manually. For actual data processing, so again, results of that process is to find 3 angles, 3 correction angles for pitch roll heading, which we have to specify for next steps. And for the final processing, Beamworks provide software utility called AutoClean. Here, process is absolutely the same as for airborne lidars. You import data using correction angles from previous step, from path test. You can clean the data applying different filters. You can remove data outside of some area, that's outside of survey region. And you may apply filters, built-in filters, to have a more dense point cloud. And finally generate a grid with data. And last step, of course, will be export of the data, because you need not only fancy screenshots as here, Standard formats will be point cloud, grids, or elevation data in GeoTIFF format, for example. So again, processes very similar to airborne LiDAR data processing, not more complex. But there is a small but important difference comparing with airborne LiDAR data. For speed of light in air, speed of light in air is in our conditions is the same. We don't need to make any corrections for speed of light when we process airborne data. For bathymetric data, situation is very different, and speed of sound in water can be very different in different conditions, depending on the type of water, I mean fresh or salt water, and also depending on the temperature. In our depth range, dependency on the pressure or depth is not very high, it can be ignored. But depending on temperature, difference can be very high. And in multibeam data, when you will start to process, you can see shapes in swash, in single swash of the data, which looks like smile or frown, comparing with the actual bottom. If you will see that 100% that wrong sound speed in water was used for data processing. It is not a big deal actually. Beamworks and Hydromagic in future, Beamworks now of course, allows to correct sound speed data. You can apply small corrections like plus minus 5 or 10 meters per second and see how data will change. When you will see that all data will form smooth line of the bottom, reflection from the bottom without some interruptions, that will mean that you find a correct sound speed in the water. That approach works in many cases. In all our surveys, we didn't use special tools to measure exact sound speed in the water, but in complex situations, you may need additional device called sound velocity profiler. At least at the moment we don't supply them, but I can recommend a couple of options. One is from Teledyne, now Teledyne. Second is from Chinese company called Hydrotech. More or less the same, differences not principal. For example, in Teledyne device you have Bluetooth or Wi-Fi interface to download data from device. For Hydrotech, you will need to open the cup and connect to device using USB cable. Even price is more or less the same. It was a surprise for me, but price is more or less the same. But again, that device may be necessary for complex situations like when there is a thermocline, for example, in pond or lake. But in many cases, you can conduct surveys and process the data with high precision, with high accuracy, without additional devices. But yeah, one more point. Multi-beam head, what we use, has temperature and pressure sensor integrated inside it, and we log data for temperature and pressure, and the data can be used to calculate sound speed in the water, but of course only for the surface where the sensor was during the survey. So I want to show you a couple of examples. Sorry. So I will show you a couple of data examples. First, I partially demonstrated. It is multi-beam data collected over our house lake. It is here, and why the data sets are very important for us, because we have a data collected using different technologies and sensors. So here we can check accuracy, repeatability, and so on of our systems. What is huge benefit of multi-beam system is obvious in data. What we can see here, we can see very small features on the bottom, which are smoothed or even totally invisible in single beam data. Next week we are planning to fully cover that lake with multi-beam data. Not only to get fancy marketing pictures and for the marketing demonstration, because some features what we see in the data raised our curiosity what we have here, because during World War II, over the Riga, close to the Riga, were heavy fights, including in air, and there are speculation about almost every second lake in the Latvia that they are fallen airplanes. So I really want to see what is that anomaly. For example, so we will survey it with multi-beam, and we will survey it with magnetometer and decide is it worth to check or not. But yeah, it's a separate story. When we will collect full data set, full multi-beam data set, we will make the data set public and you will have access to it. All raw data, processed data, generated in point cloud, and elevation data. Second data set, is collected from lake in sand quarry. Unfortunately, I cannot demonstrate the data live or make it public, or because operator of that sand query allowed us to show only screenshots without disclosing of coordinates and measurements. Sorry. But what is interesting here, the data set was collected during the system tests, and when I saw that in the data, my first feeling was the system is not working. Something went wrong with the data. But customer operator provided us high resolution of aerial photo from above, and all that pits, water here is pretty transparent, and in shallow parts of lake, all the pits were visible. And at the end, we were provided with single beam data, and we able to validate accuracy of the data. Of course, single beam data is averaged. No pits are visible, but we can compare average depth. That's the actually a good demonstration of high resolution of multi-beam data comparing with single beam. So small features on bottom are visible. So according actually to the sensor specifications, we can see features which are minimum size of couple of dozens of centimeters at the depth till 5 meters, as I remember. So very high resolution of the data. And also here is demonstration how multi-beam data, how bathymetric data can be easily combined with airborne LiDAR survey results. We collected data using LiDAR and easily combined it with multi-beam, with point cloud generated from multi-beam data. That's all, actually. We have 10-15 minutes for questions and answers. So, 1 second. First question is, assuming the payload is safe for all water conditions, mining, coil, etc. For oil, it should be, but I don't know. But our systems are heavily used in mining industry. For open pit lakes, for the tailing storages, I don't see difference between our single beam in multi-beam in that record. I mean applicability of the system. Our systems were never used to survey oil. Never used it, but yeah, why not? Why not? Second question is, what are the power requirements of your multi-beam from the drone? It is just, I don't remember. Power requirements actually nothing, practically zero comparing with the power consumption of the motors. I don't remember exact number, but it is practically zero. What is the typical resolution? Resolution depends on depth, of course. So the system multi-beam sensor has 16 beams in 80 degrees swash. So you can easily calculate resolution for the given depth. We can share link to calculator of resolution. Yes, I remember I have it in Google Sheets, so maybe we can share a link after webinar. Here you will enter the depth and bit of not magic, and you will get a resolution, and also the same calculator allows to calculate distance between survey lines for the given depth and required overlapping. Next question is, so the SBES can be used, single beam can be used as quality control tool for multi-beam data or even for calibration of multi-beam data. Yes, if you want to use, if you want to have 100%, 150% confidence in the data, you can use more simple and predictable single beam to validate multi-beam data. You can make, for example, check line using single beam, check lines using single beam. Actually, with our system, you can swap between single beam and multi-beam in few minutes. Actually, they say they use the same attachment point mounting to connect sensor to the drone, and you need to reconnect one cable for single beam and 2 cables for multi-beam sensor. Second question is the multi-beam is less precise in 3 axes? So again, hard to say. When we compare multibeam data with Apache 3 or even Ocean Alpha data and data collected using our single beam data, we see practically the same. Practically the same. Maybe we will see a real difference in more deep survey areas, because here maximum depth is around 11 meters. So here we don't see difference. But as multi-beam device is more complex and data processing is much more complex, even under the hood, you may not see complexity of the data processing, but it is physically more complex, technically more complex. That single beam data, you may expect that it will be more accurate. Second question, with the multi-beam echosounder, will it make that the survey will be done faster than with single beam? So it's a tricky question. It's a tricky question. Answer depends on required density of the data. If customer of survey is okay with sparse data, for example, for the distance between measurements line multiple meters. So for example, average depth multiplied by 3, multi-beam will not give any performance benefits. But for some types of surveys, there are strict requirements. For example, for some types of surveys described in the International Hydrographic Organization, there's quite particular requirements for bathymetric coverage and for the detection of small features of on the bottom. For example, to not miss rock in the middle of waterway. For such surveys, single beam echosounders may be economically not reasonable at all, because, for example, you will have to survey every half of meter to have a survey line. In such situation, you will make surveys much faster using multi-beam, of course. Next question is, since now it's more like LiDAR, can we talk about precision? So yeah, I partially answered on that question. So we have 16 degrees for that particular sensor, 16 degrees in 80 degrees angle, evenly distributed. So we can easily calculate a kind of ground sampling distance for or size of one measurement point of the bottom for given depth. We will provide calculator in Google Sheets. Next question: do we use hydromagic? So currently we have to use Beamworks. I know, Stephanie, that you use our system with hydromagic, I mean single beam system. They promised to release full multi-beam support, and that's almost done, except path test calibration. But it is very important part of multi-beam support. So we expect that it will be ready soon. I understand that it is very important for users of our single beam systems. Next question, will there are better devices with the M400 carrying more weight? Unfortunately, next device what I found, I mean multi-beam head, has a weight combining with the weight of all other stuff. I mean, foldable arm and so on, even capabilities of M400. But we expect that more such devices will be introduced on the market, because demand for small multi-beam heads, small multi-beam sensors exists, and not only for UAVs but also for small unmanned surface vehicles. But currently, we at least for the next say 12 months, we don't have any plans to integrate alternative multi-beam devices. Next question is, what speed do you need to fly the drone at IGS max to make sure you are collecting the data without error? So all surveys what we are doing now are at the speed 1.2 meters per second. We did short test at 1.5 meters per second. But at least initially we will recommend 1.2, because sensor head at that speed is visibly more stable when it is dragged in the water. So maybe we can in future optimize shape of the sensor housing. It is currently quite optimal. I can show you in high resolution how it looks. So it is shape of housing. But of course, there are some possibilities for optimization. We use computational fluid dynamics to optimize shape, but yeah, actually it is eternal process. So currently recommended speed is 1.2 meters per second. Next question from Mohammed. Two questions. Are multi-beam use same frequency? I think the same as our single beam sensors. No, frequency is different. That sensor uses acoustic frequency 240 kilohertz. If the question about sediments, sound with that frequency will not penetrate through sediments. So it is kind of analog in terms of penetration, analog of high frequency echosounders, single beam echosounders. And second question from Mohammed, any difference for marine or drone multi-beam? I don't understand the question, actually. It will work in fresh water, it will work in salt water, in any liquid, technically. The only key is to know sound speed in liquid. Next question, any firm timeline on M400 integration? It's the most popular question, maybe, at the moment. It is not only for multi-beam, but for all our portfolio. Unfortunately, DJI changed everything. They even slightly changed physically connector to connect external computer. They changed PSDK, software part. They changed requirements for hardware interface. Now they require encryption chip at the side of on the side of onboard computer connected to the drone. They changed diameters of legs, arms. They changed attachment points below the drone. What does it mean? I hope that first working sets we will have in September or maybe in October. I'm pretty confident that we will start shipping of systems for M400 till the end of year. Current situation that we are still trying to establish communication between drone and our onboard computer. To understand the complexity of the task, DJI still didn't provide full documentation. So when you are starting to dig deeper, you will navigate on some link and will see some wiki pages on Chinese. That's the current state. So that situation was the same with all new DJI drones. They roll out product on the drone, and after that, eventually they roll out real support in SDK, in documentation, and so on. So we, at the moment, we are at the first steps of the process. Next question is, in its current format, can multibeam data be processed in HydroMagic? If it's attempted, what will be the negative effect on data? So again, in HydroMagic, you can process data if you know three magic numbers for pitch, roll, and heading correction. And we are waiting implementation of that important function in HydroMagic. That function or block of functions called patch test for the kind of calibration of the system. In theory, you can collect the data. Alicia, I know that you have maybe multiple licenses of HydroMagic, but in theory, you can set collected data to us. We can do calibration and send it back to you. But news that in HydroMagic, anyway, you will need to buy to purchase additional license for multi-beam functionality. So that functionality will not came for free for the current users, unfortunately. And price for Beamworks multi-beam suite is quite affordable, I should say. Quite affordable. Next question. How is the distance measured between the drone and the multi-beam? Does the altimeter play a role here? Excellent question, Bart. So, Beamworks software used some block of data called survey vessel configuration or vessel profile. It describes all physical parameters of the survey system. So currently, our system is described as vessel, which has an RTK receiver in the middle, close to the center of gravity, and it uses towed fish by cable with multi-beam system. With a known distance in vertical and offset from center of gravity for the multi-beam head. Actually, for what we made that video, to visually estimate angle or offset, we can measure angle of arm actually, because we have IMU in multi-beam head, and we are working on the most simple vessel configuration when we will geotag the data, not with coordinates of drone for that point, but with calculated coordinates of multi-beam and elevation and altitude of multi-beam head itself. It will make data processing bit simpler. But in the tested range of survey speed across recommended 1.2 meters, we will supply vessel configuration for Beamworks. The difference will be actually plus minus 5 centimeters, and it is nothing for even most strict requirements for bathymetric surveys. Guys, we have 65 open questions. I would propose to limit 10 minutes more, 10 minutes more. And on the rest of questions, we will answer in written. And actually, when we will prepare the answers, we will distribute all questions and all answers to all of you. I hope that it will be acceptable. So for 10 minutes, I will continue to answer questions. Next question. In the video, I see the sensor behind the drone, how it's the position of the sensor behind the drone calculated, actually already answered. Already answered. We know that angle, we can calculate offset, and we check the offset for recommended survey speed. Next question is how the system works in lower medium wind speed and sea near shore. How system works in the low or medium wind speed and sea near shore. We recommend to use to not use the system with wind which will exceed 5 meters per second, constant speed or wind gusts. That means that waves except surf zone will be less than half of meter, and altitude of the drone above meter is approximately 1 meter, bit more. And if over the kind of normal waves, which are not too rough, drone will go up and down together with waves. It is tested many times with our single beam systems. They use it around the world for surf zones and for the shallow coastal areas where it is not possible to use manned or unmanned boats. But of course, there are limitations for the maximum wave heights. We don't recommend higher than half of meter. Next question is, this means we need to observe the sound velocity profile ourselves using other platforms. Yeah, question is related to how to get know sound velocity. First, we log water temperature and pressure. Pressure is not significant because we collect in our scenario multibeam head is right under the surface, but we collect temperature, and if you know the type of water, fresh or salt, you can easily find on internet sound speed for that temperature of particular water type, kind of water. Second option is I describe it. You made slight corrections of the during processing until you will not see all parts of the data connected, making smooth profiles of the bottom. In complex situations, my personal opinion that you really have to have sound velocity profiler to collect data according to water column for sound velocity data for the water column only is in very complex situations like thermoclines in water bodies. And sound velocity profilers can be used with the drone as well, because profilers, what I recommended, they are fully self-contained devices. You need just to put it to the water and pull back, and it will record coordinates at the point of entrance to the water and data for the different depth. Next question is, can this be used in fast-moving water bodies, or what are its limitations in surveying rivers? Recommended limit is is the same 1.2 meters, but not absolute speed, but speed relative to the flow speed. Great benefit of drone that you can make surveys in lines aligned with flow direction and speed. Our customers of single beam systems use that technique to make cross sections in fast rivers. Drone should fly not perpendicular to the river, but in parallel lines aligned with the flow. But for that scenario, I don't see huge benefits of multi-beam. Maybe single beam will be better and more predictable. Next question is, can you PPK the multi-beam data, or it is still just RTK? In that configuration, only RTK. That configuration, I mean DJI drone, because it's quite strange technical solution for me, but DJI log RINEX data, full GNSS receiver data, only in the memory of DJI payloads only. In theory, you can attach some small light DJI camera to the drone and conduct survey in PPK mode. And RINEX data will be logged on in memory card of payload. Second option is to use additional PPK receiver on top of the drone. Many our customers do that. They use lightweight and not expensive PPK receivers like MLIT Reach M2. We also use that configuration when we need to use PPK. For non-DJI drones, it depends on drone model, and but in general, answer in general. That's the limitation of the drone. There is particular DJI drones, and there are different workarounds. For non-DJI drones, it is possible to find right configuration, both for RTK and PPK. Next question is from Alicia as well. In relation to my previous question, can single beam data be processed properly in Beamworks? I think yes, but I never tried except single beam data, full wave single beam data recorded in SIGWAI files. I never tried, but it should be. It should be. Sorry, I don't know. Next question is, how less precise is it? So again, in our current tests where we have benchmark data, we see the same. We see the same accuracy and precision. Maybe we will see difference in case of deeper water bodies. We are planning to make surveys of the some small areas of Baltic coast, but I don't show that we will be able to fly far away to have data from up to 50 meters, because bay here is very shallow actually. But now I don't see principal major differences. Next question is, can you use other softwares to calibrate the data? Also, what is the maximum depth that a multi-beam sensor can reach down? So maybe you can from sonar view. You can using sonar view, you can import data in SVLOG format, proprietary format of Cerulean, and export it, for example, in format called common sensor format, generic sensor format. As I know, it is supported by many software packages, and yeah, why not? But testing of workflow is, at the moment at least, is up to you, because we are tested Beamworks and HydroMagic, and at the moment we recommend Beamworks as fully ready solution, and we expect that multi-beam support will be ready in HydroMagic very soon. So what is the maximum depth of multi-beam sensor? For that multi-beam sensor, maximum depth according to manufacturer is 50 meters. 50 meters, 50. Next question is how the draft is handled in acquisition software. So we know speed. We know offset, and we know the vertical, horizontal and vertical offset for the recommended speed, and also we can check that using data from EMV. So currently it is kind of constant value for recommended survey speed. For very different survey speed, it should be adjusted. But also we, as I already mentioned, we will in next releases of our data logging software, we will change data logging. We will log data with coordinates elevation of multi-beam sensor itself, not for the drone. Next question is, do we have longer video? I would like to see the multi-beam when the drone turns. Yes, it will be published soon. It will be published soon. And still 60 questions, 59 questions. So I will answer 2 last questions, guys. If the multi-beam work with DJI M600, sorry, but no. Our latest versions of software don't support that old DJI drone. First of all, because DJI fully dropped support for it, they don't answer on any support questions from us. I mean, related to software, bugs, issues, and so on. Support for new sensors require new features which are not available for all DJI drones. So currently we support M300, M350. Support for M400 will be introduced soon, and we support non-DJI drones with Pixhawk autopilot. Pixhawk, I mean in common. Cube, orange cube, black cube. For us, important that it should be Ardocopter firmware in autopilot. And last question, what I will answer. We did not try drone flight in UAE in open sea areas. Is it allowed as per your knowledge? Yes, we have. You will have a copy of that presentation, and here actually are links. Maybe we have some examples of here for example, yeah, weather is calm, but it is sea. It is close to Florida, as I remember. Yeah, Florida. Open pit lakes. Here. Quite brutal photos. So in such situation, it is with single beam with longer cable, but not such extreme conditions. You can use, of course, also multi-beam because principle is the same. It uses real-time altitude measured by radar altitude. So, okay, two bonus answers to Bart. Is multi-beam head has sound velocity sensor installed? Answer is no. It has temperature sensor installed, and when you know temperature and water type, fresh or salted at least, you can find you can estimate sound speed at the surface with quite high precision, and precision enough for that depth range, I mean. And last one is the path test required on every mission or every start of flight. It is required only for one time when you configured the system. When you assembled the system first time, most probably before paid job or big project, you will want to test it, and during the test you need to collect data for the calibration. You will find magic triangles for the pitch roll heading correction, and that angles you may use for all next surveys if you will assemble the system exactly in the same way, if you will use the system exactly in the same configuration. So that's all.